Good day everyone, this is the Chapter 2 Network Design Essentials. Network design. In this section, you explore the basic of good network design. These include analyzing network requirements and selecting a network topology and the equipment to fit that topology. Following that information are pointers on how to map out your design. Designing a network layout. Before designing a network layout, it is important to understand some basic networking concept. When you implement a network, you must first decide how to best situate the components in the topology. A network's topology refers not only to the physical layout of its computers, cables, and other resources, but also to how those components communicate with each other. Topology, layout, diagram, and map are some of the many terms used to describe this basic design. In standard topologies, all network design in use today are based on three topologies: bus, star, and ring. A bus consists of a series of computers connected along a single cable segment. The topology of computers connected via central concentration point or hub is a star. Computers connected to form a loop create a ring. Bus topology, also known as a linear bus. The bus topology is by far the simplest and at one time was the most common method for connecting computers. Inherent in this simplicity, however, is a weakness. A single cable can halt the entire network. All components of the bus topology connects via a backbone, a single cable segment that interconnects all the computers in a straight line. Bus communication. To understand fully the impact of choosing a bus topology, you must understand how computers communicate with each other across a network. All computers, regardless of their topology, communicate in the same way. They address some data to one or more computers and then transmit that data across the cable in the form of electronic signals. Sending the signal. When a computer has data to send, it addresses that data, breaks it into packets, and sends it across the network as electronic signals. These signals travel the length of the cable segment, and all connected computers receive them. However, because of the address given to the packets, only those computers for which these signals are destined accept that data. Signal bounds. As a signal travels across the network medium, it moves from point of transmission to both ends of any bus. If allowed to continue unchecked, such a signal would travel across the network continuously, bouncing back and forth, preventing other computers from sending data. A terminator attached to each end of cable prevents signal from bouncing. This terminator absorbs all signals that reach it, thus clearing the network for new communication. Star topology. A star topology describes computers connected by cable segments to a central hub. When a computer sends a signal, the hub receives and retransmits it down every other cable segment to all other computers or other devices attached to that hub. All computers hear the signal and check the destination address, but only the computer to which the data is addressed processes the data further. Ring topology. When each computer connects directly to the next computer in line, a circle of cable forms to create a ring topology network. As a computer receives a signal, it either acts on it or regenerates it and passes it along. Signals travel in only one direction around the ring. Because the circle has no end, termination is not required. A ring topology network can be wired as a star. A central hub may pass the token through the network in a virtual ring, which supports the benefits of both topologies. Wireless topologies. Wireless networks eliminate the need for a visible physical topology, which is one reason for their growing popularity. There are no cables to run, terminate, and test. However, wireless networking does the topology associated with it. In the simplest wireless configuration, two computers can communicate directly with one another in a peer-to-peer topology, sometimes called an ad hoc topology. This type of arrangement is usually only used in a small or temporary installation. Hubs. As mentioned, a hub is a central point of concentration for a star network. There are two types of hubs, active and passive. Active hub, also called the multiport repeater, regenerates signal and passes it along. Passive hubs is simply central connection point with no amplification or regeneration. Hybrid hubs maximize network efficiency by interconnecting different types of cables and topologies. Switches. A switch, like a hub, is the central connecting point in a star topology network. However, unlike a hub, the switch does more than simply regenerate signals. A switch looks just like a hub in that it has several ports for connecting workstation in a star topology. These are the variations on the major topologies. Four variations of major network topologies are combinations of topology. First, extended star. Second, mesh. Third, star bus. And the last one is star ring. Extended star topology. The extended star topology is the most widely used topology in networks that contain more than just a few computers. As the name implies, the extended star topology is a star of stars. A central device, usually a switch, sits in the middle of the topology, and rather than attach computers forming the arms of the star, other switches are connected to the ports of the central switch. The second is mesh topology. A mesh network topology is the most fault-tolerant but also the most expensive. Connecting each device in a network to every other device in the network creates a mesh network topology. Any single cable or device failure in a mesh configuration affects network performance only minimally because multiple connections exist to each devices. The third one is star bus topology. The star bus topology, as its name states, combines a star and a bus. For example, a star bus topology is implemented when a bus backbone interconnects two or more hubs. The star configuration minimizes the effect of any single computer's failure on the network. If a hub fails, the computers attached to it cannot communicate, but other hub computer connections remain intact and communication continues. The last one is star ring topology, a network that is wired as a star but that handles network traffic like a ring is a star ring topology. Again, a single computer failure does not affect network traffic. Several outer hubs can connect to the inner hubs, extending the inner ring.